Hello everyone. Welcome to the 12th tutorial session of Probability Foundation for Electrical Engineers, whose instructor is Professor Kirna Jagannatha from IIT Madras. So here I am Satya, AP Research Scholar at the Department of Energy Science Engineering, IIT Bombay. So this is the 11th tutorial session, and that will help you to solve the 11th assignment of this course. So the next class will be of the last assignment based tutorial session. So yesterday also I have taken one class which was the means revision based session, which may help you to solve the problems which is going to come in the examination. Okay, so moving forward, so here is the first problem for you to solve. Okay, so here question is such that ki if a discrete random variable x which takes the values from 0 to 1, 0 or 1, so and its expectation of x is equal to zero point 0.6, then what is the probability of p is x is equal to 1? Okay, you have to find out the value. Okay, if you face any doubt, just let me know in between. Okay, let me give the solution for this. So it is asking that if a discrete random variable x is there, so there is a random variable x which belongs to, means take the value from the either 0 or 1. So it is being said that expectation of x is given as point c. It is asking what is the probability of x is equal to 1. Okay. So how to solve it? Step 1 is that what are the values are given, that is x is either 0 or 1, and expectation of x is zero point 0.6. Okay. So what is the probability of x is equal to 1? So when you see that expectation of x in the discrete form is equal to summation xi, probability of x is equal to xi. Okay. And here it is given that it can be expectation of x is equal to either 0 or 1. So when you take si is equal to 0, it means that probability of x is equal to 0 plus 1, probability of x is equal to 1, because there are two values only. So xi multiplied by pxi, px0 it is 0 and px is equal to 1 is equal to 1. Okay. So it is equal to probability of x is equal to 1. It means that expectation of x is equal to probability of x is equal to 1, which is equal to zero point 0.6. No, sorry, is equal to expectation of x, which is equal to zero point 0.6. Okay. Now what it is asking? It is asking probability x is equal to 1. So this is equal to zero point 0.6 only. Okay, you have to cross check. This is optional. You can check with the complement also, that probability of x equal to 0 is equal to 1 minus x, it is zero point 0.6. So answer is actually zero point 0.6. Okay, so correct answer is option A. Let's move forward, try to solve this problem. Here the moment is given mxt is equal to e to the power 2t plus 3t square. You have to find out what is the mean and variance of the x. Use the formula. Okay, let me give the solution for this. In this problem, it is saying if mx of t is equal to e to the power 2t plus 3t square. So what is the value of mu and what is the value of variance basically? Okay. So here movement generating function mgf of x is mx of t is given as e to the power 2t plus 3t square, and if a random variable x has a this movement generating function mxt, then what is the definition basically? So expectation of x is basically equal to mx of differentiation basically at a value of 0, and variance is equal to variance of x is equal to mx double dash 0 minus mx dash 0 of square. Okay, so you already have know that mxt is equal to e to the power 2t plus 3t square. Okay, okay, differentiate it. Differentiate when you differentiate it. Okay, one second. Mxt is equal to e to the power 2t plus 3t square. Okay, let's differentiate it. When you differentiate mx dash of t, it will become e to the power same value 2t plus 3t square and then 2 plus 60. Okay, put the value mx dash 0 is equal to, this will become 0 and this will become 1, so this is equal to 2. Differentiate further, mx double dash t is equal to, when you differentiate it, it will be simply 2 e to the power 2t plus 3t square multiplied by, again you will find out like this. Okay, 2 plus 60 plus, okay, plus 6t e to the power 2t plus 3t square, 2 plus 60 plus, or you can say that multiplying it by like this, 6 e to the power 2t plus 3t square. Okay, what is the value of mx double dash t? It will simply will become, this will become 0 here and this will become 4, this will become 0 plus 60. When you put it here, it will become 0 plus here also it will become 6, it's simply 10. Okay, so what we have got? We have got mx dash 0 is equal to 2. Here we have solved that. Here we got the 0. Here also we got the mx double dash is equal to 10 here. So what is the expectation of x? Expectation of x, that is simply equal to movement. When you have the movement generating function, just differentiate it and put in the value of 0. So it is simply equal to 2, and variance of x simply is equal to mx double dash 0 minus mx dash 0 of whole square. Okay, what is mx dash 0? That is 10 minus 2 of whole square, that is 6. Okay, so expectation of x, or you can say the mean mu is equal to 2 and the variance is 6. So correct option, if when you see here, the option C matches with the option. Okay, so here also you can see when you have the movement generating function for finding out the mean or the variance, you just have to for the mean you just differentiate it and put the value 0 and in the movement generating function, and for finding out the variance just take the double derivative mx double dash 0 minus mx dash 0 of whole square, so you get the two values, put in the equation and you get the final mean and variance of the movement generating function. Okay, let's move forward, try to solve this problem. Here also the MGF is given, so it is if the y is given as ax plus b, you have to find out what is the movement generating function. Here the reverse is there, you have the value equation is given and you have to find out what will be the movement generating function of the y is equal to ax plus b. Okay, let me give the solution for this. So when you see that what is in the problem is asking if y is already given, that is ax plus b, and you have to generate that key, find out the what is the moment generating function. Okay, let's go by step by step. So when you already have this equation which is y is equal to ax plus b, and you have to generate the means you have to generate the moment generating function basically. Okay, so moment myt is basically being defined as expectation of e to the power ty. Okay, or you can say any of the equation which is given. Okay, here y is equal to x plus b equation is given, just you have to put it there. Okay, here you can define it t times of fx. Okay, which is being defined here as y is equal to x plus b, y is equal to ax plus b. Okay, now what you have to do, uh, write it like the function that expectation of e to the power t, y is equal to ax plus b. Okay, let's put it here. Okay, now expectation of, here you can separate it out, e to the power bt or e to the power a t times of x. Okay, okay, now e to the power bt, because you are generating the function in terms of in terms of t. Okay, so but equation constant which is not dependent upon x, you can separate it out, consider it as a constant. Okay, so because expectation of, when you have the ax, you can write it in the form of a times of expectation of x. Okay, you can take the constant out. Here also we are doing the same. E to the power bt, expectation of e to the power at times of x. Okay, so here you can say this is the moment generating function mx of at. Okay, e to the power bt is equal to myt. Okay, that is similar here. Okay, so here you can say that in the form of mx to the power 80. When you see here the mx in the form of 80 80 80 is given. Okay, so here you can say the myt, the moment generating function of y is equal to x plus b, is simply e to the power bt. You can take it now mx 80, e to the power bt mx 80. Option b is actually matching. Okay, so here what you have to do, there is a simple formula for the moment generating function for deriving. So expectation of e to the power ty, and you just put it the value of the y here and take the exponent, means constant out, because the expectation of when you're having the constant multiplied with some function, you can take it out the constant part, and also conclude here like simply you can see that in the terms of 80 is given. So just you have to find out here t in terms of 80. Okay, let's move forward. Try to solve this problem. Here the asymmetric means ki question asking that ki if there is a symmetric random variable x about 0, and the odd movements are okay, there are even movements are also, and there is odd movements also, so you have to just focus on the odd movements where it will actually lie. Okay, Okay, let me give the solution for this. So in this question, it is being said that ki, for if there is a symmetrical random variable x, so there is a random movement and random variable is there. So it is symmetric about the zero. Okay, so it is being asked that what is the odd movements? It is always positive, although negative, zero or undefined. Okay, so if it is x is symmetric about zero, so x is you can say that that is x division when you see it is equal to in the domain that is minus x, and an odd moment has the exponential this expectation of x to the power 2 to the power k plus 1 because the even is 2k and the odd is 2k plus 1 for k belonging to a natural number which include the 0 as well. Okay, so for symmetry to elevate, you can find out the expectation across x is equal to 2 to the power k plus 1. So put the value here, you can get the minus x k power to the power k plus 1, and simplify that because it is a constant, you can take it out minus 1 to the power 2k plus 1. That is simply minus an expectation of x to the power k plus 1. So here hence the expectation because the movement which is there at the central point that is actually 0, so where the movement exists is finite. Okay, so by the intuition also you can check that mass at x is equal to minus a cancel is the sum integral of the power or powers. Okay, so it is basically the 0. The correct option will be C. Option C, actually 0. Okay. Let's move forward. Here, the characteristic function is being asked of a standard normal random variable function. What will be the answer? Okay. Try to find it out. Let me know if you have any doubt. Okay, let me give the solution for this. So it is asking that you have a characteristic equation of a standard normal random variable. So you have to find out what is the character equation of that. So basically that it is already given that it's a normal distribution in 0 to 1. Okay. So if it is already given that you have the random variable x, which is a normally distributed in between 0 to 1. So you have to define what is the characteristic equation of that. Okay. Simply defining the characteristic equation is simply the expectation of e to the power I t x. X we already know, here it is normal distribution in 0 to 1. Okay. So let's find it out. Just keep the values. This is minus infinity to infinity e to the power I t x fx of x dx. Okay. Fx of x is a probability density function of x that is simply defined. So substituting the this probability density function, because we already know if it is a random variable function, it is will be equal to 1 upon under root of pi 2 pi e to the power minus x square by 2. Keep the value here. You will find out phi x of t is equal to minus infinity to infinity 1 upon root 2 pi e to the power I t x e to the power minus x square by 2 dx. Okay, let's move forward. When you're keeping the values here, e to the power minus, though you can combine the exponents also like this. E to the power I t x e to the power minus x square by 2, combine it, e to the power minus x square minus 2 I t x by 2. Okay, you can write it multiplying by this. You can also write in the form of whole square form also. E to the power x square minus 2 x plus t square minus t square divided by 2. Separate it. E to the power x minus it of whole square e to the power minus t square by 2. Okay, so simplifying that, phi x of t, you already know, we already defined that e to the power minus t by 2 1 upon root pi. This is we are separating the values from only taking the values of x only. So here the overall integral become minus infinity to infinity e to the power minus x minus it of whole square by 2 dx. So when you integrate it, the integral terms equal to the 1, because it's a minus infinity to infinity e to the power minus x square by 2 only. It's means a shifted normal distributed by the it terms only. So this will be become 1. So the final phi xt will become e to the power minus t square. Okay, so characteristic function which is defined on the standard normal variable will be equal to e to the power minus t square by 2. Simply here, because in the problem it is asking that you have to define the characteristic function phi x of t. X is already given that normally distributed in between 0 to 1. So phi x of t is equal to simply in the by definition that expectation of e to the power I tx, and phi xt for the continuous variable, that is minus infinity to infinity e to the power minus I tx fx of x dx. Put the value of fx of x, that is 1 upon root pi e to the power minus x square by 2. So keeping the value there, you can find it out that 1 upon root pi e to the power I tx e to the power minus x square by 2 dx. Separating and taking the square values at the same time, that is e to the power minus x square minus 2I tx by 2. Then add t square minus t square and subtract with the same t square only. So it will become e to the power minus x minus it of whole square and multiplied by e to the power minus t square by 2. So the final result that you can see that this is a normal distributed that PDF which is shifted by IT term only. So in the normal distributed function. So here also you can say that this integral will become, when you integrate minus infinity to infinity, it will become 1 only. Okay. So the final result phi x of t will become e to the power minus t square by 2. So characteristic equation of a standard normal variable will be e to the power minus t square by 2. That is option A is correct, e to the power minus t square by 2. Okay. So in the next problem, it is saying that if it is a movement generating function of x which does not exist for any t does not equal to 0, then x it is, it is having a finite mean, or x is a Cauchy distributive function, or x is a normally distributive function, or x having the finite variance. Just you have to see that key movement generating function of x which is not existing for any of the t does not equal to 0. Okay. So their existence is at t is equal to 0 only. Okay. So the existence is at t is equal to 0 only. So we have to define it that whether x is having a finite mean, or x is a Cauchy distributed function, x is a normal distributed function, or x is having the finite variance. Okay. Take your time and let me know what is the correct answer. If you have any doubt, just let me know. Okay, let me give the solution for this. When you see that the question what is telling that if the MGF of x which is does not exist for any t does not equal to 0, then it is asking x is a finite mean, or x is a quasi distributed function, or x is a normally distributed function, or x has a finite variance. So when you see here the MGF of x, that mx of t, it is being defined as expectation of e to the power t to the power x. Okay, and it does not exist. It does not exist at for any t does not equal to 0. Any t does not equal to 0. Okay, so key fact about the MGFs are if mx of t is a finite on an open interval around 0, so the MGF which exists and uniquely determines the distribution. So some heavy tailed distribution which have no MGF except at t is equal to 0. Okay, so there are having the uniquely determined distribution system which is heavily tailed distributed. Okay, so, how to identify the canonical case? So, Cauchy distribution is a classical example. So, it's a MGF diverges for any every of t does not equal to 0. While characteristic function exists, moreover, the Cauchy have the finite mean and the no finite variance. So, option A and D are false. Okay, so the A and D will not be coming to the finite case. So, but when you see that a normal distribution, which is option C, it having the moment generating function e to the power mu t plus half of sigma square t square. So C is also false. Okay, C is also false. Okay, so the conclusion is that case statement which matches with the given condition is standard probability theory settings, which is x is a Cauchy distributed function. Okay, so the option B is actually correct. Okay, let's move forward, try to solve this. So in this problem, it is saying that which inequality provides a upper bound on probability of x minus mu greater equal to k sigma. Okay, Marcos inequality, Jensen's inequality, Chebyshev inequality, or Holder's inequality. Just try to solve it and let me know which inequality which provides the upper bound of probability of x minus mu greater equal to k sigma. Okay, let me give you a solution for this. So it is saying that which inequality provides the upper bound of this upper bound of probability of x minus mu greater or equal to k sigma. So when you recall the inequalities, the Markov's inequality, it applies to a non-negative random variable and bounds that x is equal to greater or equal to a. Okay. Jensen's inequality, it relates with the convex functions and the expectations. And Holder's inequality is bound the integrals and expectation, which is used in the analysis part. And Chebyshev's inequality, it gives a bound on the deviation from the mean using the variance. So when you write the Chebyshev inequality, it is says that for a random variable with mu, mean is equal to mu and variance as sigma square. So probability of x minus mu greater or equal to k sigma is less than or equal to 1 upon k square. K is greater than 0. So interpretation will be such that it tells us that the probability that x deviate from its mean by k or more standard deviation is at most 1 upon k square, regardless of the distribution shape as long as the variance exists. So answer is the Chebyshev inequality, which is option C is actually correct. Okay, so here the inequalities, there are different equalities. Marcos inequality, which applies to non-negative random variables and bounds that probability of x greater or equal to a, and Jensen's equality, which relaxes the convex function and expectations. Holder's inequalities bounds the integrals and expectations, which is used in the analysis part, and Chebyshev inequality gives a bound on the deviation from the mean using the variance. Okay, so the when you write the Chebyshev inequality for a random variable with mean mu and variance sigma square, so probability of x minus mu greater equal to k sigma is less than equal to 1 upon k square. Okay, so k is greater than 0. So interpretation says that it tells us that what the probability that x deviates from its mean by k or more standard deviation is at most 1 upon k square, regardless of the distribution shape as long as the variance exists. So correct answer will be Chebyshev inequality, option C. Let's move forward, try to solve this problem. Here also it is stating that when you have the Chebyshev inequality and if the probability of x minus mu is greater or equal to k sigma is less than or equal to 1 upon 25, then the k is equal to. It's a easy problem we have already seen in the equality part. Just try to solve and find out the value of k. Okay, let me give the solution for this. So it is saying for each ABC inequality, if probability of x minus mu is greater or equal to k sigma is less than or equal to 1 upon 25. So simply when you see the Chebyshev inequality, it is simply probability of x minus mu greater or equal to k sigma less than or equal to 1 upon k square. So and we told that it is given that 1 upon 25. So when you compare 1 upon k square with 1 upon 25, you can get the k value as plus minus 5, but the positive value we will take, so it is plus 5. So deviation bound of 1 upon 25, it correspond to the 5 standard deviation from the mean. So k is equal to 5. So the correct answer is option D. Let's move forward, try to solve this. In this problem, it is stating that if expectation of x is equal to 3 and variance is given as 2, find out the maximum value of probability of x minus 3 greater or equal to 2. Okay, try to solve this. Okay, let me give the solution for this. So in this problem, it is saying that expectation of x is given as 3 and variance is given as 2. So what is the maximum value of p when x minus 3 is greater than equal to 2? When you say here using a Chebyshev inequality, it is simply that probability of mod of x minus mu greater than or equal to a is less than or equal to sigma square divided by a square. Okay, here mu is given as 3 and sigma square is given as 2. Okay, so here a is equal to 2 and mu is equal to 3. Okay, keep the value here. So when you say mod of x minus mu is 3. Okay, greater than or equal to sigma square, that is 2 a. Okay, is less than or equal to sigma square, the value is 2 a square value is 2 square. Okay, that is equal to 1 upon 2 basically. Okay, so what you got, probability of x minus 3 greater than or equal to 2 is less than or equal to 1 upon 2. Okay, so the what is the upper point here? So when you say the maximum value which is tied to the upper boundary from the Chebyshev, that is 1 by 2. Okay, that is 0.5. So when you see here, option A is actually matching with the correctly. So it's a zero point 0.5, option A. Let's move forward. Try to solve this. Almost sure that convergence, which implies that convergence is the probability or convergence is the distribution or both or neither. Try to solve. Let me know which option is correct. Okay, let me give the solution. So here it is saying that almost sure convergence implies that convergence is probability, convergence distribution, or either both. When you've been asked that almost sure, it means the convergence of xn tends to x is implying. Okay, not exactly, but it is implying or tending to x. So when you say the almost sure, so it means that when you take the limit from n to infinity, xn is equal to x, that will be equal to 1, and convergence is the probability when the epsilon is greater than 0, and probability of xn minus x is greater than epsilon is tending to 0. Okay, and when you say the convergence the distribution, so it is the fx of n x is tending to fx of x, okay, for all continuity point of the fx. Okay, so a standard implication chain, you when you see the in fundamental result, so xn is almost sure that it is tending to x, and same with the probability also. When you see xn is probability p, similarly with the distribution. So conclusion is that when you say that both surety is there in the convergence or the distribution also, so the probability with existence format it will be correct. Okay, so the option both will be correct. The convergence, the probability, convergence, the distribution as well. Okay, try to solve this. This is a simple problem. We have already seen the how to crack this problem before as well. Okay, let me give the solution for this. So it is almost sure that ki xn is tending to x almost surely, then x of 2n is tending to x. Okay. So when you say that xn is tending to x almost surely, so using the continuous mapping theorem, so let gx is equal to x square. So since G is a continuous everywhere, so Xn is as similar to the X. So is similar to the Xn square. So it is implying tends that Gx is equal to X square. So Xn square is tending to X square almost surely. So this option is option A, that is almost surely, which is implying that Xn of 2n to the X. Okay. Let's move forward. Try to solve this problem. Okay, let me give the solution. So when you say, it is saying that xn is independent and summation of p probability of mod of xn is greater than epsilon is less than infinity for all epsilon greater than 0, then xn tends to 0 is in probability, xn tends to 0 almost surely, xn diverges or xn converges in the mean. Okay, when you say that xn are independent and mod of n summation of n n is equal to 1 to infinity, probability of mod of xn is greater than epsilon is less than infinity for every epsilon greater than 0. Which tool we are using? Using the Borel-Cantelli lemma, where it is being said as summation of, if the probability of summation of probability of mod of n is less than infinity, then probability of an I will be equal to 0. Applying to the same our events, that an epsilon, that is mod of xn is greater than epsilon, so then the same with the probability, it will be equal to 0. Okay, so the option B is actually matching with the correctly, so this is almost surely. Okay, let's move forward and try to solve this, and let me solve this problem first. Okay, then we will move forward. Okay, let me give the solution for this. When you see that xn is a sequence of the random variable defined on 0 to 1, such that xn is equal to 1 on the interval of the sinking length, then xs. So here also the almost the when you have epsilon in between the 0 to 1, probability of xn minus 0 is greater than epsilon. So probability of xn is equal to 1 is equal to mod of in tends to 0. Xn tending to 0 is a P. So almost your convergence would require Xn S tends to 0 for almost every S. So from the Borel Cantelli, this old will be some that, but we can only given that amount of In is tending to 0. So not the summably. So but one can choose that In so that every point lies in infinity. Okay, many In. So the correct option will be option A. Let's move forward. So this is last problem of the today's session. So this is a probability that the weekly output mean is given as 50, mu is given as 50, which exceeds 75 is bounded above by the Chebyshev inequality as. Okay. Try to solve this. Okay, let me give the solution for this. So it is saying that you're having the probability x is greater or equal to 75 with mu is equal to 50. So the deviation when you see it is 75 minus 50, that is equal to 25. So by the Chebyshev inequality, it is probability of mod of x minus mu is greater or equal to a, less than or equal to variance of x of divided by a square. So probability of x of greater than 75 will be probability of mod of x minus 50 greater or equal to 25, and less than equal to variance of x divided by 25 of a square. Okay, so if variance of x is equal to 25 and sigma is equal to 5, then probability of x is greater or equal to 75 is less than or equal to 25 by 625, that is 1 by 25. So this will be equal to less than or equal to 1 upon 25. So correct option will be equal to 1 upon 25. Okay, so that's all for the today's tutorial session. Have a good day.